Okay, so similar shapes then, intermediate tier, C grade at Gcse. So all I've got then, I've got past paper question, and let's go through it. Right, so let's go for a highlighter. Shapes A, B, C, D. So A, B, C, D, so this shape and E, F, G, H are mathematically similar. Not identical, not congruent, which is what identical means, but similar. So they are very similar to each other. You will notice that the angles are the same, and that's the first note I'm going to put over here. Angles are always the same. Always the same when shapes are similar. Right, now you can see, looking at these lengths now, this shape is slightly bigger than this shape. But when they're similar, they're bigger in the same sort of scale factor. Now you can see this left-hand side, we've got one measurement, but not this one. This top measurement, we've got this measurement, but not this one. Sides we haven't got, but you'll notice on both shapes, we've got the bottom measurement. Now we can use that to try and find our scale factor. Scale factor is how much bigger or how much smaller another shape is compared to the previous one. Now, to get from 6 centimetres to 9 centimetres, yes, we are just adding 3. However, it's got to be times or divide. Has to be those. Times, multiplication, or divide. It can't be add or take away. So, also, to go from 6 to 9, we are multiplying it by something. Now, half of 6 is 3, and add that on as 9. So we know that 9 is 1.5 times bigger than 6. If you didn't know that, easy way you could do it, do 9 divided by 6 equals 1.5. That gives us a scale factor of 1.5. So our scale factor is 1.5. So we've worked that out. Now underneath this in a GCSE exam, it would ask us to calculate certain things. It could ask us to calculate a different length. So I'm going to use this blue pen here and have an X here. Okay, so we can easily work that out. Now that line there is called BC. Okay, so let's have a look at BC now. That's where I've put the X. So this BC, if this is 8 here, to work out that length, as you can see, this shape is 1.5 times bigger. So all we do to this 8 is multiply it by 1.5. Half of 8 is 4, add it on, so therefore BC is 12 centimetres. How about then if you wanted to work out this one over here, this EF? Well, this one's 7.5, but this one is on the smaller shape, so our answer for this has to be smaller than 7.5. But how much smaller? Well, if this shape is 1.5 times bigger than this one, then to get from 7.5, we need to divide by 1.5 to get this here. Now 7.5 divided by 1.5 is 5 centimetres. So all we're doing, we're working out the different sides, the unknown sides, by using the scale factor and looking for a common length of the shape that we can use to calculate our scale factor. So those notes look a little bit messy, but remember, always angles are always the same. Use the scale factor if it's getting to the bigger shape, it's multiply, to the smaller shape, it's divide. Let's try one with some triangles. Okay, right, let's make that a bit easier to read. Okay, so diagrams are not accurately drawn, however, they are similar. So similar, you need to find a scale factor. So I'm going to pick the side that has a has a measurement on both of them. You can see it's the bottom one here. So scale factor, 6 divided by 4, again, is 1.5. So this shape is 1.5 times bigger than this one. Well, let's work out a couple of sides here. Let's go for this side here, this QR. Well, if this one's 12, and the scale factor is 1.5, to get from the small shape to the big shape, we times it by 1.5. Now, half of 12 is 6, add it on is 18. So that means QR, this one here, is 18 centimetres. This one here, if this side, the left-hand side, is 15 centimetres, to break down to the smaller similar shape, we have to divide by 1.5. 15 divided by 1.5, so AB, 15 divided by 1.5 is 10 centimetres. But remember, these angles are all exactly the same on here as it is on here. Now, if it's 1.5 times bigger, your brain is telling you, oh, well, everything else has got to be bigger, as in the angles. But no, remember, there are 180 degrees in these three angles. It doesn't matter if your triangle's really small or really big, it doesn't matter, the angles still all add to 180, therefore they have to be the same. If I've got an angle here, just here of 70 degrees, and the scale factor is 3 times bigger, there's no way this angle could be 210 degrees, because the angles inside the triangle add up to 180. So remember, angles are always the same. These two questions have been quite nice because the scale factor being 1.5. You could have a scale factor of 2, it could be a scale factor of 3, or even 2.5, but realistically, most of the time, it'll either be a whole number or a 0.5. So just check your numbers, be extra careful, and look for that keyword, similar. As soon as you see similar, your brain should go, oh, find the scale factor, and angles always stay the same.